Okay, here we go with some hints for WW4. Question 1, find the inverse function. So the way we find inverse functions is we change the f of x to y equals 5x plus 2 in this case. We take the 5x plus 2 and we rewrite it as x equals by taking the positive 2 over, taking the 5 over. Once you've written it as x equals, then remember we need to write it back in terms of x. So the y's that are over here, change them to x's in your answer. Question 2, function of a function question. So we have f of g of x, and then we've got to subtract g of f of x. So we need to do two replacements. So the first replacement is that the g goes into the f formula. So that means taking the x squared plus 1 and putting it in here for the x. If we do that, then we have x squared plus 1 plus 2. And then we've got to subtract, we don't know what, so let's put a bracket. Now for the second one, we're going to have to put the f formula into the g formula. So that means taking the x plus 2 and sticking it in here for this x. And if we do that, we have x plus 2 squared plus 1. Now all we've got to do is a bit of algebra, remove all the brackets, tidy it up, and you should get a relatively straightforward answer. Question 3, find the perpendicular bisector. So we just go through the processes. First thing we need to do is we need to find the midpoint. So add the x's and y's together. Second thing we need to do is find the gradient of PQ. That should be easy enough. That will then lead you to the perpendicular gradient. And then we're just going to use this midpoint, this perpendicular gradient, in your y minus b equals mx minus a formula. Question 4 is in 3 parts. The first part that we've got to do is A right angle to C? So first thing we need to do is we need to generate our little a, which basically just turns this into a column vector. So 1, 2, negative 3, and our little b, which is 2, oops, a minute, it's not working properly, 2, 2, 2. Okay, now if they're perpendicular, then a dot b is going to equal 0. So we take the a, the 1, 2, negative 3, we take the b, which is 2, 2, 2, and we dot them together. Now remember, when we dot them together, we do the first thing in this bracket times the first thing in this bracket. So 1 times 2, 2, and then we add on the second thing in this bracket times the second thing in this bracket. So put that in there, and then we add on the third thing in this bracket times the third thing in this bracket. Add it all together. If it comes out to be 0, perpendicular. If it's not, it's not perpendicular. The second part of the question says, is the length of A add C equal to the length of A take away C? So first case we need to work out is, what is A add C? So take your two column vectors again, add them up, see what you get. Then take the two column vectors and subtract them for A take away C. What do you get? And then you need to work out the length of the vector. Now remember, when you work out the length of a vector, so in this case A add C, then we do the square root of the first thing in this bracket squared plus the second thing in this bracket squared plus the third thing in this bracket squared. Okay, and then do the same for A take away C and have a look at your two answers and see if they're the same or not. When it comes to part 3, we've just got to find out if we dot these two answers together we get 0. So looking at your two answers that you got for A add C here and A take away C here, just dot these two answers together. So again, first thing times first thing second thing times second thing, third thing times third, do the dot product, see if you get 0. Okay, oops, I didn't realise there's a whole page for that. So, just quickly again, you've worked out this vector, you've worked out this vector, dot them together by doing this times this, this times this, this times this, add them all up. Okay, so you've got an answer, add an answer, add an answer, see if it's equal to 0. Question 5, cos alpha is 3 over 5, cos beta is 4 over 5. We've got to find what cos alpha take away beta is. So the expansion for cos alpha take away beta is cos alpha cos beta plus sin alpha sin beta. Okay, now let me shrink this a wee bit. We know from the question that cos alpha is 3 over 5. We've got that up here. Cos alpha is 3 over 5. We know that cos beta is 4 over 5. So we can put them together and times them. Now we need to add on what sin alpha is and sin beta. We don't know those, so go back to your first expression, draw a little triangle, alpha in here, cos alpha 3 over 5. Do a bit of Pythagoras, tells you that side's 4. We can now write down what sin alpha is. Sin alpha 4 over 5. Put that in here. Do the same for sin beta, so another triangle, work out sin beta, multiply your two fractions together and do an add sum. Question 6. When is this function increasing? The word increasing should tell you that you have to differentiate. Okay, so differential of x cubed is 3x squared. Differential of 3x squared is 6x. Differential of 2 is 0. So we just have 3x squared minus 6x. How do we know where that's increasing? We need to find the stationary points. So we're going to put 3x squared minus 6x equal to 0. We're going to solve that, and it's going to give us two answers, x equals, x equals. Now what we're going to do with those numbers is that we're going to make up a nature table. Okay, so as you get closer to the first one, between them, after the second one, and we're going to get a picture which might look like this. It might look like this. Who knows until you actually try it. Once you've managed to get what it looks like, so let's say it looks like this example here, this would be the place it would increase in. So it would be between this number and this number. It might be that, might not. Don't take my word for it, you work it out. Question 7. I'm not too sure if we've done this in class. If we have, it's called synthetic division. So we put the number 2 here, the number 3 here, the number -9 here, and the number -10 there. Okay, now what we've got to find is a number that goes in here, so that when we go through our processes, if you've done it in class, you'll know what those processes are. We're trying to get a 0 here. Okay, once we've done that, we'll have x and a number, and then we'll have another factor which comes from this part here, which you could then factorise into 3 brackets. Question 8, simplify this log. Please, please, please do not just go 27 divided by 9 is 3. Okay, do not do this. So that's log to the base 3. 27 divided by 9 is 3. Log to the base 3 of 3, so the answer is 1. Okay, we do not do that. What we need to do is we need to turn the top log to the base 3 of 3 to the power something. And we need to do the same on the bottom. Log to the base 3 of 3 to the power something. Why are we doing that? The reason we're doing that is because this little power here is going to nip down the front. This little power here is going to nip down the front, and then these will cancel out, and you'll be simply left with the top power over the bottom power for your final answer. Question 9. Where does this point lie? Well, if you want to work out whether points lie on or off circles, straight lines, curves of any sort, simply substitute in. So 3 goes in here for x, 2 goes in here for y. So we're going to have 3 take away 4 squared plus 2 add 2 squared, and we're going to compare it to 18. Now if this answer comes out to be 18, so if you get 18 equals 18, it's on the circle. If it's a number less than 18, then it's inside the circle, and if it's a number bigger than 18, it's outside the circle. Okay, so you should be able to work that out from there. Question 10, done a load of these. So expand, so k cos x cos alpha plus k sin x sin alpha. Okay, work out what your k sin alpha is, work out what your k cos alpha is. Okay, these will be the numbers for the front here, either 2 or 1, put them in here and here. That allows you to work out k squared, which allows you to work out k. The first part allows you to work out tan, and you'll have your values for k and for alpha. The question, got to try and maximise that. Well, you have to write it as k cos x minus alpha. So it's going to be based on a cos curve. So if you remember what the cos curves look like, looks like that. It's a maximum here when x equals 0. Okay, so for your answer, this number is going to be your maximum, the k is going to be the maximum, and it happens when the angle is equal to 0. Or in other words, when the x minus alpha equals 0. So plug that into your formula and you can simply work out what the value of x is. Last question, possibly the hardest one. Got to find the equation of a tangent. So we need a point AB and we need a gradient. So what do we know from the question? We know from the question, let's make that a wee bit weird so I can actually get it all on the page here. We know from the question that the x coordinate is 4. So how are we going to work out the b number, the y coordinate? Oh, look, here we've got a little formula that says y is equal to. So if you put the number 4 in this formula, then that's going to tell you what your y coordinate is. Secondly, how are we going to work out the gradient? Well, the gradient in a curve means we need to differentiate. So if you differentiate that expression, remember the way we're going to differentiate this is we're going to split it up into x over root x plus 2 over root x. Right, simplify that and then differentiate it. Okay, let me take this out here, because this isn't a dy by dx, this is actually y. We haven't actually differentiated it yet. So we're going to differentiate that, and then we're going to substitute the 4 in. That's going to give us the gradient, and then we're going to use y minus b. Now we know it looks horrible with all those root signs, but the numbers come out to be fairly simple. Okay, so some hard stuff there and some easy stuff for you.